We have learned on how to perform inverse of a 2 by 2 matrix. Now let us learn how to perform inverse on a 3 by 3 matrix. And in our previous video, we learned on singular matrix, and we know that when the determinant is equals to 0, the matrix is non-invertible. Now for a 3 by 3 matrix, it's different. We know for a 2 by 2 matrix, let's put it somewhere here. For a 2 by 3 matrix, we have A is equals to, let's say, A, B, C, D. The inverse of A, okay, will be equal to 1 over the determinant of A in the matrix of DA and minus C minus B. Now this is for a 2 by 2 matrix. Now, but for a 3 by 3 matrix, now something different occurs. Instead of having this new set of matrix, we have something called adjoint of a matrix. Adjoint of a matrix. And now adjoint of a matrix A is equals to transpose of the cofactor. C is the cofactor. C is the cofactor. Now we have learned of all these things. We know certain of some certain things. Okay, we know some certain things. We know how to perform the transpose of a matrix. We know how to perform determinants. Now all we just need to know is how to evaluate the cofactor of a matrix. Once you know the cofactor, we take the transpose of it and we get the adjoint of the matrix. Once we get the adjoint of the matrix, we will get the inverse of the matrix. Now, since it's going to be a long series of videos, we are broken it down into steps. We'll first learn how to evaluate cofactors. All right, then after we learn the cofactors, we'll transpose the cofactors together. Thereafter, we evaluate the determinant, and finally on the inverse. So we have two questions here. We have A and we have B, both 3 by 3 matrix, and we are to evaluate the inverse of the two. So let's begin with that in the next video. How do we know cofactors?